Welcome back to the lecture series on heat transfer operation. This is Yogesh Lange. In this video, we will see a derivation on the dimensional analysis for natural convection. So, dimensional analysis for the natural convection. So, let's assume the heat transfer coefficient by natural convection in tube is a function of the following variables. So the variables are d, rho, k, mu, h, cp and delta t, beta g, where k is the thermal conductivity of the fluid, mu is the viscosity of the fluid, h is the heat transfer coefficient, cp is the specific heat, delta t is the temperature gradient, and this beta is the coefficient of expansion of a fluid, and g is the acceleration due to gravity, which is in meter per second square. So the conductivity, it is in watt per meter Kelvin. Viscosity is mu is the viscosity of the fluid. H is the heat transfer coefficient. It is watt per meter per meter square per Kelvin. Specific heat is in joule per kg per Kelvin. Delta T is the in the degree Celsius. So these are the unit. So first, before making the table, we have to write the unit, and that unit should be in the dimensions. And for that one, we know that the H, it has had a unit of watt per meter square Kelvin. Now the meter we can write in terms of the L, K is in terms of the T, because we are considering the four fundamentals quantity, that is mass, length, temperature and time. But watt, it is not, we are converting in these four dimensions. So what we do, we first converting the watt into joule per second. So we are writing watt is nothing but the joule per second. Now the joule, again we need to convert, because again it is not, we can write in terms of the four fundamentals. So what we do, we again write the joule is nothing but the Newton meter. So watt is joule per second, joule is Newton per meter, and the Newton we are converting into the kg meter per second square. This conversion we know that. Okay, so after converting the watt into joule per second, the joule into the Newton meter, and Newton is in terms of the kg meter per second square, we get the final dimension in terms of the dimensions, that is the mass, this is the time, that is noted by small t, and the k, that is the temperature. Similarly, another term which we have, it is cp, it is in joule per kg per Kelvin. So we are converting this joule, again joule is converted into the Newton meter, Newton is converted into the kg meter per second square, and then we will get the final equation in terms of the dimensions, the fundamental dimensions that we are considering, that is mass, length, time and temperature. Similarly for the K, the conductivity of the fluid, and for that one what we do, we are writing the watt per meter per Kelvin, and for that case we are converting the watt into the, again the same joule per second, a same process that we follow. Okay, so Newton meter, and this is converting into the kg meter per second square, and we will get the last form in this one. So if you see here, the unit of H, we can write it is kg per second cube Kelvin. We can write the unit of Cp as a meter square second square per Kelvin, and we can write the unit of conductivity, it is kg meter per second cube per Kelvin, and all these are given in the form of all fundamental dimensions. Okay, so after this one we make a table. So this is the table, so you can write the variables. So variables are a tube diameter, density of the fluid, thermal conductivity, fluid viscosity, heat transfer coefficient and specific heat of a fluid, and these are the symbol d, rho, k, mu, h, cp and this way. Now we write the unit. So d is in terms of the meter, density we know that it is kg per meter cube, conductivity we already write that unit in terms of the mass, length, time and temperature. So we write it is kg meter per second cube per Kelvin. So similarly you have to put it all the unit in terms of the so that in terms of the dimensions. So, and here we are writing the all the dimensions. So m can be written as L. So dimensions is the length we can measure into we write as a symbol L. For the mass we write it is m. For the temperature we write capital T, and for the time we write small t. So on the basis of this unit we are writing the dimensions. So once we make this table, then we use with the help of the Buckingham pi theorem, we try to solve what are the dimensions in this one. Okay, so this table we can make it after that one. So once we make this table in terms of the dimensions, we are very much interested in this symbol and the dimensions, because after that one we use the symbols and these dimensions. On these dimensions we try to get the what are the dimensionless number in it. So we choose the first group, the core, that is we call it is a core group. It is L, rho, K and mu. So this group we kept is common. Okay. And on that basis we are writing, and remaining the H, Cp and the delta T, beta G, that we take up as the second one. So core group is L, rho, K, mu. So we write pi 1 is equals to the L raised to the power A, rho raised to the power B, K raised to the power C, mu raised to the power D, and the one variable it is H. Similarly for phi 2, I am writing L rho K mu I kept constant, and the Cp I added another variable. And the third one I am writing the same, this is core group as it is L rho K mu, only the change. So H is here, here is the Cp, and here is the delta T beta G. So this is the term. Now the case is why I am writing all the pi 1, pi 2 and pi 3. So we have the 7 variables and there are the 4 fundamentals. So as per the Buckingham pi theorem, we can make a 3 groups, because 7 minus 4 it will give 3, and that is a 3 group we can make it. Okay, now we will solve one by one a first group, and from this one we try to get which dimensionless number that we will get, from this one which dimensionless number we will get, and from the equation number 4 which dimensionless we will get. Okay, so from the pi theorem we say that there are the 3 dimensionless number. So let's see which are that. For the pi 1 term, this is the equation 2, pi 1 equals to the L rho K mu, this is H. Okay, now what we do, we write the dimensions. So we write the dimensions. So how? So from the table we have this table already, we make it. So this d L is nothing but the d. So here I write in the dimensions L. Okay. So rho, I keep the value of rho dimensions here. What is the dimension of rho? It is m L raised to the power minus 3. So I kept here the K conductivity. So this is the dimensions. So I kept here. So mu here and H here. So I write this equation in terms of the dimensions as L, M, T and capital T. So I am writing this the left hand side for the pi 1, and the power is 0. And here we are writing the 4 powers A, B, C, D for this core group, and that is it is for L from the dimensions raised to the power A. Rho is m L raised to the power minus 3, so I am writing m L raised to the power minus 3 whole raised to the power b. Okay, similarly I am writing for the k. The k is m L t raised to the power minus 3 t raised to the power minus 1 whole raised to the power c. Similarly I am writing for mu. The dimensions are this one, so I keep here the dimensions, these dimensions here raised to the power d, and the variable h. And what is the dimensions for h? H is this one, m t raised to the power minus 1 t raised to the power minus 3. So I am taking here. So I write this equation in terms of the dimensions. Now I am comparing the left hand side and right hand side and write the equations so that I can get a simultaneous equation and that I will solve. So first I am take the dimension L and just see left hand side L raised to the power 0 and this is the right hand side. Now take the power, compare this, write the equation in terms of the power, and for the power we can write as the L is equals to here. So L left hand side it is 0, so I make it power 0. On the right hand side, see where is the dimension L. So L is here, here also the L, here also the L, in this also the L, and there is no L. So what I am doing, I am writing the powers. I add the power. So L raised to the power A, so I am writing here A plus, what is L? L is here, but L raised to the power minus 3 or raised to the power B. So as per the power law, we know that L, we can write this as 3 into B. We can multiply this one. So I am writing minus 3B. Why I am writing minus 3? Because here is the minus. That's why I am taking minus 3B. Plus I add all the powers of it. Okay. So addition of the power. Plus C, L is here raised to the power C. So I am taking it is power C. Here is the L raised to the power minus 1 into the this power D. So it is minus D. So I am writing it is minus D. And that is equals to 0 because I am taking from this one. So this is the term for L. Similarly, I am doing for the M for small t and for capital T. So I check the M. Where is the M? Here is the M. Here is the M. Here is the M. And here is the M. And again writing the powers and add the powers. So I add the power. Here is the power B. M raised to the power B. There is M raised to the power 1 means B plus M raised to the power C plus M raised to the power D plus M is here, and here is the, there is no constant power, so here we consider it is 1. Okay, that's why we write plus 1. M raised to the power 1, that is nothing but the power 1. Similarly, I am writing for the D, that is minus 3C minus D into minus 3. Okay, so again we see where is the T term. There is no T term, no need to write. Here is the T term, so I am writing T term. Here is the T, so I am writing this T. Here is the T, so I am writing here. Okay, and then for the temperature, so for the temperature I am taking no term is here, there is no term, temperature is here, T raised to the power 1 into the C, so I am writing minus C. The T upside, the T raised to the power minus 1 raised to the power 1, so it is minus 1, so I am taking this is minus 1. Now what I do, I solve this as a simultaneous equation. So I am solving the simultaneous equation and I get what is the value of power, and on that basis we can judge which is the dimensionless number. So for this one, first I solve it. After solving the equation, simultaneous equation, I get the value of A is 1, B is 0, C is minus 1, and D equals to the 0. So first we solve this one, C is equals to minus 1. Then put the value of C here, you will get the D. Put the value of C and D, you will get the value of B. Put the value of BCD, you will get the value of A. So after solving this equation, I got these values. And now I take this equation pi 1 equals to the, we know that the L rho K mu H. Now what I am doing, I know the power is of this one. So A is 1. So what I am doing, pi 1 is equals to the, put the value of A here. So L raised to the power 1, B value here, B 0, so rho raised to the power 0. The C value is here, okay, the power K raised to the power C, it is minus 1, so I am taking this K raised to the power minus 1, and D is equals to the 0, so here is the D is equals to 0, and H is the power 1. Now after putting the power, so obviously this as per the power law, this is the 0, okay, 1, and this is the 1, so you just remove this part and we have a pure equation, that is pi 1 is equals to the H into the L, and K raised to the power minus 1 means it is by K. So HL by K is nothing but the Nusselt number. So from the first equation pi 1, we get a dimensionless number, that is a Nusselt number. Okay. Similarly, we solve for the pi 2 and pi 3. How? Let's see. Now for the pi 2 term, we write the equation pi 2 equals to the L rho k mu. Only that instead of h, there is a Cp. Okay. Again, I follow the same process that I write the dimensions for L rho k mu. I write the dimensions for the L, for rho, for k and mu. And then I write the dimensions for Cp with the help of the table. And I make the equation. So this is the equation. L, M, T and T is equal to, this is the equation. So it is the first four terms are similar. So once you do in a first step, no need to do again. You have that one. You can just take the reference from it. And the last term is CP. CP is dimensions are L square T raised to the power minus 1, T raised to the power minus 1. Okay. So this is the dimension in terms of the dimensions. Now what we do, we try to solve the left hand side and right hand side and add the power. So we are adding the power here. So L term is here, so that's why I take it L. Here is the L. So first I am trying to find the L because I am doing for L. Okay. So one dimension L. So I am writing, I add all the powers. So I add the powers. Then for M, again I find where is the term M. On the space M raised to the power 1 into the B. So it is B plus, here is the M plus C. Here is the M plus D. So accordingly I am writing all the terms. So I write this one in terms of L, M, T and capital T. And now I solve this one on the basis of the simultaneous equation. So after solving the simultaneous equation, we get the value of A. Now A is 0, B is 0, C is minus 1 and T equals to the 1. So what I do? I just collect the powers. After taking that one, I write these equations and now these four equations I solve simultaneously and I will get these values. Of C is obviously it is minus 1. Put the value of C here, you will get the value of D. C and D, then you will get a B, B, C, D, you will get the value of A. So on that basis we solve it. And now this power you have to put in this equation. So pi 2 is equals to what? A is 0, so I am writing L raised to the power 0, B is 0, rho raised to the power 0, C is minus 1, so K raised to the power minus 1, and D equals to the 1, so mu equals to mu raised to the power 1. So I am writing CP. So I am writing this equation by putting the powers. So this is cancelled term and only we got a K raised to the power minus 1, mu 1, mu raised to the power 1 and CP. So we write this equation, that is pi 2 is equals to the Cp mu by K. And this group is nothing but the Prandtl number. So how many dimension group we get? We get a two dimensions number. One is the Nusselt number and another is the Prandtl number. The same process, we write this equation, we write in terms of the dimensions, we write in the equations in terms of the dimensions and solving the equation, and we will get this power, and that power we just put it here, you will get the equation. Fine. So Prandtl number is there, and again we take for writing these dimensions we take the help of this table. And the last one, the pi 3 term, again I am writing the equation L rho k mu. This is the core group we consider. Okay, A, B, C, D is the power. And this is the another term that we add delta T beta into G. So again the same thing we do. We have this table. Okay, with the help of this table we are writing the dimensions of L rho k mu. Then we write the dimensions for delta T beta G, and delta T beta G it is dimension L into T raised to power minus 2. Okay, so we put all this one and we write the equation, and that equation is this one. So the pi 3 we write in this form, and then we write all the dimensions whatever it is here, and then we are add and compare the left hand side equals to the right hand side and the power addition. So what we do here, we take for L, we write the equation, we write equation for M, see the m is 0, that's why here 0, and see where is the m, just wherever it be the m, that power you have to add it. Similarly for small t and capital T. Okay, and after the solving the simultaneous equation, we get the constant power, that is the a is equals to the 3, b equals to the 2, c equals to the 0, and d equals to the minus 2. Okay, so after that again we put this power in this equation. Okay, the same process we follow, and we get this equation. So 3a is equals 3, so 3 is put here, b put 2, c 0, and d is minus 2. So we got this equation L cube rho square delta t beta g by mu square, and this number is nothing but the Grashof number. So we get three numbers from the three equations, pi 1, pi 2, and pi 3. And now what is the relation between the Nusselt number, Prandtl number, and Grashof number? So as per the pi theorem, we can say that from the Buckingham pi theorem, pi 1 is a function of pi 2 and pi 3. Now what is the pi 1? Pi 1 we solve and we get the value, the dimension number. It is the Nusselt number. Pi 2 it is the Prandtl number, and pi 3 is the Grashof number. So we can write this equation as Nusselt number is a function of Prandtl number and Grashof. Thank you very much for watching this video.